Hello guys, welcome to my YouTube channel. My name is Kennedy, and in today's video we are going to talk about how to do calculations when you forget the formula. So what do you do when you've forgotten the formula? How can you still calculate, or how do you do calculations without having to memorize all the formulas? One of the common complaints students have is that there are too many formulas. I can't memorize all of these things. So let's see how we can at least boycott some of those formulas and not have to memorize them and still be able to answer questions correctly. First question is this. A 76-year-old man is admitted to the hospital because of a 2-week history of a persistent urinary tract infection. He is 165 cm height, weighs 55 kg, BMI is 20 kg per meter square. The physician plans to initiate treatment. A component of the initial treatment includes an intravenous bolus dose of an antibiotic to attain an initial peak serum concentration of 8 mg per liter. The volume of distribution of the antibiotic is 0.35 liter per kilogram. Lab studies show a 24-hour urine creatinine clearance within reference range. Which of the following is the most appropriate loading dose of this drug in this patient, or for this patient, in milligram? So when you look at this question here, what they have done is give you the question and then give you the answer. The MBMEs and USMLE questions always have at least 2 routes of answering the question. So whether you think of it this way or you think of it this way, you should be able to arrive at the answer. That's how you actually cross-check to make sure the more methods you know of arriving at the answer, the more likely you're going to be correct with the answer. So you can cross-check your answer from this angle and also look at your answer from this other angle. If both of them correspond, you can be at least certain of that particular answer. So the first way to answer this question is that you actually know the formula for loading dose. So loading dose is serum concentration multiplied by volume of distribution over bioavailability. If you know the formula for loading dose, then good. You solve this question. It's still possible you're going to fail it if you know the formula for loading dose. But with this method we are going to use, it is almost impossible for you to miss this question. As a matter of fact, you can do a simple test with yourself. If you know the formula for loading dose, actually solve this question, pause the video, solve the question, and then see if you made the common error a lot of people make when they use that formula for loading dose. Okay, so what you have to do is write out all the units in a straight line like this. The unit for height, weight, BMI, plasma serum concentration, volume of distribution. Just put them in a straight line as I have done here. And then you want to pick units that when you combine them together, either by multiplication or division, are going to cancel out themselves in a way to leave milligram standing alone. If you do that, you're going to get something like this. You're going to get kilogram. It's going to appear like this if you do that. What you notice is you don't really need the height, you don't really need the BMI. And the truth is that with most of the calculations we do, we don't need to use the height and we don't need to use the BMI. When you combine this, if you multiply these units, kilogram would take out kilogram, liter would take out liter, and we would have milligram standing alone. When you put these out, kilogram was the unit for weight, so you're going to have weight multiplied by milligram per liter was the unit for serum concentration, and liter per kilogram was the unit for volume of distribution. Therefore, I can say that loading dose is equal to weight times serum concentration times volume of distribution. The actual formula says loading dose is equal to serum concentration multiplied by volume of distribution all over F, which was bioavailability. But you would know that, you would remember that bioavailability is always one, like 100%, 1, once the person is given the medication IV. And every question on the USMLE is always going to be IV, so you don't really need to use bioavailability in your calculations on the USMLE. Now, what is the most common mistake students make? Students will do serum concentration times volume of distribution and give an answer. Most students forget to use the weight. Did you use the weight? If you make that mistake, you'd probably have gotten a wrong answer. If you did it right, you should get, I think, 150 as the answer to this question. Let's do the second question and see what we have. Second question. So the units, you write out the units as we did before. You have milligram and microgram per liter. So somebody's going to say, oh, Kennedy, yes, we need to give the answer in liter, but then we have milligram and microgram. They cannot cancel out themselves because, well, they're not the same. What do? You have to convert milligram to microgram. To do that, you multiply by 1000, right? 1000 microgram make 1 milligram. So I can multiply my milligram by 1000. And then if you notice here, liter is the denominator. So if we divide from mathematics, right, then this expression becomes this. Now milligram can cancel out microgram. Technically, it's like you have microgram because we've multiplied milligram by 1000. So the units are technically now the same thing. And that is why this method is better, because a lot of students will do this calculation and forget to convert milligram to microgram. If you do that, you would see when you look at the answer choices, you see 1.2, 12, 120, 1200, and 12,000. If you don't do the conversion properly, you will fail this question, even if you know the formula. That's why I prefer this method. I don't forget to make the units line up correctly, and that pretty much helps make sure that you are accurate. So when you do that, you divide out. Now your formula becomes 4.8 multiplied by 1000. Remember, we converted milligram to microgram, multiplied by 0.4 microgram per liter, and that will give us 1200, or 12,000 rather. Okay, the third question I'll leave for you to do by yourself. Answer this question. What do you get? Tell me the answer in the comment section. If you get it right, I'll give you a thumbs up. I'll probably tell you got it right, and you'll probably get your first congratulations for 2021 from me. I'll see you in the next video. Please remember to leave a like on this video. The more likes you give to the video, the more likely the YouTube algorithm will show it to more people and would help more students get one more question right on the USMLE. Thanks once again. I'll see you in the next one.